Good morning, students. Welcome back after a small gap. I hope all are fine and doing well. Right. So, in today's video or next video, we are going to say bye-bye to the kinematics chapter. In order to say bye-bye to the kinematics, first we are going to just recall what we have discussed in the last videos. First, we started the kinematics and we said that kinematics is a branch of mechanics which deals about the motion of bodies without cause of motion. And we have discussed the difference between distance and displacement. So what is the difference between distance and displacement? And we have discussed some problems between distance and displacement. So distance means the total path length traveled by the body is known as distance. When you come to the displacement, the shortest path between initial position and final position. Initial position and final position. And also we have discussed about speed, velocity, and types of speed and types of velocities. And finally we have discussed about acceleration. All we have discussed in the previous class. What we are going to do means we are going to just recall this by using some problems. So first, take down the first problem. A car moves from A to B with a speed of 30 km per hour and returns from B to A with a speed of 20 km per hour. Find the average speed of the car to the whole trip. So let us consider this is A and this is B. A car is moving from A to B with 30 kmph, 30 km per hour. B to A with a speed of 20 km per hour. A to B it is 30, B to A it is given as 20. Now we want to calculate the speed, that is with a speed, average speed. We know the formula for average speed. What is the formula for average speed? That is total distance by total time. Total distance by total time taken. Here there is no total distance and there is no total time. In order to do like this problem, there is a small shortcut. That is average speed equal to 2 into V1 V2 by V1 plus V2. So when we want to use this type of formula, means when the total distance and total time is not given, in that case we are going to use this formula average speed equal to 2 into V1 V2 by V1 plus V2. Here V1 we are going to take as 30, V1 equal to 30 km per hour. V2 that is 20 km per hour. Right, now we are going to calculate here 2 into V1 that is 30, V2 that is 20 by 30 plus 20 that equal to 2 into 30 into 20 by 30 plus 20 that is 50. So 0 gets cancelled. So 2 into 2, 4 into 30 that is 120 by 5. 32 is okay. 120 by 5, what is the value? That equal to 5 ones, 5 2s 10. So 2 will be remainder. 2, right? 5 2s 10, 20. 5 4s 20. That is 24 km per hour. So the average speed of the car is 24 kilometer per hour. So this is the method to do the problems when distance and time is not given, only the speed is mentioned. Okay. In this way, in the same way, we are going to do another problem and we are going to recall some of the terms. Okay. Until, right. See, next problem. A body moves with a velocity of 10 meter per second due east. After 10 seconds, its velocity changes to 10 meter per second towards north. Find its average acceleration. We know that acceleration means change in velocity by time. Here we should remember that velocity, it is an example for vector. Vector means it will have magnitude and direction. Now, so vector, it is a vector, velocity is a vector, it will have magnitude and direction. If the velocity changes when magnitude changes or direction changes or both changes. So now we are going to do this problem. So find its average acceleration. So first we want to draw the diagram, that is, this is east, west, north and south. Now a body moves with a velocity of 10 meter per second due to east. So in the east it has moved 10 meter per second in this direction, east. So in order, here 10 gives only magnitude, but here the velocity is a vector, it should have direction. So in order to represent that the body has moved along the east, we are going to represent with I cap, 10I meter per second. Here 10, it represents magnitude. I, it represents that the body has moved along the horizontal direction. Here I is positive, so it says that it has moved along the positive x-axis. If you write minus 10I, it says that it has moved along westwise. If you write 10J, it says that the body moves northwards. If you write minus 10J, it says that the body has moved towards south. Here, remember that here I, J are the unit vectors. We are going to discuss the vectors chapter in the next video. In that time we can understand clearly. Up to now, just have an idea. Here I, J represents the unit vectors. So 10I meter per second. It says that it has moved 10 meters per second along the x-axis. Now the velocity changes towards north. Again it has moved like this, 10 meters. What's that? Here it is moved north, so we are going to write as 10J. Here J represents that the body has moved along north direction. Now we want to calculate average acceleration. So average acceleration. So formula for average acceleration is change in velocity by time, change in time. Here delta V represents change in velocity, delta T represents time. So change in velocity by time. So change in velocity means final velocity minus initial velocity. So final velocity, that is 10J minus initial velocity 10I by time. It takes 10 seconds to change the velocity. So 10. Now we are going to take 10 common from the numerator. Then it becomes J minus I by 10. 10 gets cancelled. That is J minus I. Here it is average acceleration. But we are going to calculate the magnitude for this. How to calculate the magnitude? So we are going to calculate magnitude of average acceleration. How to calculate magnitude for a given vector? So square root of coefficient of j before 1. So before j it is 1. So 1 square plus coefficient of I, that is minus 1 whole square or minus 1 whole square. So that is square root of 1 square, that is 1 plus 1, that is root 2. So average acceleration is root 2. In which direction it will be in? It will be in this direction. That is along the northwest direction. So I request the children for 6th and 7th, you have just an idea about this average acceleration, displacement, speed, and in order to understand these problems, you want to do number of problems, then you can easily understand. Okay, now we are going to see another problem. Okay, coming to the next problem. A ball thrown vertically with an initial speed of 20 meters per second. When it has reached 3/4 of maximum height, speed of the ball is. Already we have discussed some more topics, that is time of ascent, time of descent, maximum height in the last previous video. Based upon that, we are going to do a problem. So we want to calculate the speed of the ball at 3/4 of maximum height. We know that. Let us consider it is a ground. Now, from here, a ball is thrown vertically with a speed of 20 meters per second. We know that as the body moves upwards, its velocity decreases, and at one point, that is at maximum height, the velocity becomes g. After that, it returns to the ground. We know why the velocity of the body decreases, because due to gravitational force, the velocity decreases. But here the question is, what is the velocity or what is the speed of the ball at 3/4 of maximum height? Let us consider this is the maximum height of the body, h max. This is the maximum height of the body. Now we want to calculate the speed of the ball at 3/4. At here, 3/4 of maximum height. So at this point, what is the speed of the ball? Now we want to calculate. So the given values of initial velocity is given. We already know that initial velocity is represented by the letter u. U equal to 20 meters per second. A, that is minus, we want to take, by which the body is moving vertically upwards. A, that is minus g, that is equal to minus 10 meters per second square. And at the same time, s is also given. S, that is 3/4 of h max. S equal to 3/4 of h max. What is the formula for maximum height? Already we have derived in the last video. The formula for maximum height is u square by 2g. Very good. H max equal to u square by 2g. Now we want to calculate the value of v, final velocity, at 3/4 of maximum height. Now we are going to use one of the kinematic equation, that is v square equal to u square plus 2as. This is the one of the third kinematic equation. Now we want the value of v square. V square equal to u, that is 20. So 20 square, that is 20 square means 20 into 20 plus 2 into a, it can be written as minus d, right? Minus d into s, that is 3/4 into u square, that is u, 20 square means 20 into 20 by 2 into g. So v square equal to 20 into 20, that is that is 400, plus into minus 2 into g, 2g into 3/4 into 20 into 20, that is 400 by 2g. G gets cancelled. 4 ones, 4 hundreds. 400. 3 twos, right? 2 gets cancelled. 3 into 100, that is 300. V square equal to 400 minus 300. Therefore, V square equal to 400 minus 300, that is 100. V equal to the square, when square goes to that side, it becomes root. V equal to root of 100. So, root of 100, that is 10. So, 10 meter per second. When it reaches to the 3 by 4th of maximum height, the velocity will be 10 meter per second. Okay. Now, we are going to see another problem. Into the final problem of today's class. So, see the problem. A ball is dropped downwards. After 1 second, another ball is dropped downwards from the same point. What is the difference in distance between them after 3 seconds? Look at the first, a ball is dropped from some height. After dropping, they have waited for 1 second and they have dropped a second ball from the same point. Now, we want to calculate the difference in distance between the two balls. That means, how to do this problem is, first, we want to calculate the distance travelled by the first ball in 3 seconds. After that, we want to calculate the distance travelled by the second ball after 1 second release of the first ball. That means, we want to calculate the distance travelled by the second ball in 2 seconds only. Why means, here the total time is given as 3 seconds. But the second ball is dropped 1 second after the first ball. So the time for the second body will be 2 seconds. And the time for the first body will be 3 seconds. So first we are going to calculate the distance travelled by the first body in 3 seconds. So we are going to calculate distance travelled by the first body in 3 seconds. So it is freely dropped. Initial velocity is 0. Acceleration A equal to plus G, or we can take 10 meter per second square. Time, it is given as 3 seconds. Now we are going to calculate the distance travelled by the first body. So S equal to S1. Now we are going to substitute in the one of the kinematic equation. S equal to ut plus half at square. Yes, what is the value of S? S1. U, 0. 0 into 3 plus half into A, 10. Into T, that is 3. That is 3 means 3 square. 3 square, 3 into 3, that is 9. 2 ones, 2 fives. 9 into 5, 45. So S1 equal to 0 into 3, 0. 0 plus 5 into 9, 45. 5 9s, 45. S1 equal to 45 meters. That means in 3 seconds, the distance travelled by the first body will be 45 meters. In the same way, we are going to calculate the distance travelled by the second body. But only one difference, we should note that. For second body, the time should be taken as 2 seconds. Why we want to take the time for 2 seconds means, the second body is released after 1 second. There is a time gap of 1 second between the first body and second body. So this is important. So T equal to 2 seconds. Remaining is same. Initial velocity for the second body is also 0. A equal to G plus G, that is 10 meter per second square. Now we are going to calculate the distance travelled by the second body. Same formula, but S equal to S2. S equal to, we are going to substitute in the formula, S equal to ut plus half at square. S equal to U, 0 into 2 plus half into A, that is 10 into T, 2. that is 2 square, 2 into 2, 4. So 2 ones, 2 fives. So S equal to 0 into 2, 0 plus 5 into 4, 5 fours, 20, right. S equal, sorry, in the place of S we are going to write S2, 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 S2 equal to 20 meters. This is the distance travelled by the second body in 2 seconds. Now he asked the difference. Difference means S equal to S1 minus S2. That is 45 minus 20. S equal to 25 meters. So the distance between these two bodies will be 25 meters. I request the 6th class and 7th class students not to bother about these problems. So these problems can be understood if you do number of times. Don't bother about these problems. You must learn what is distance and what is displacement and the main concept. We already covered some problems, small problems. For example, when a body completes one full circle, the displacement is 0. Distance is 2 pi r. In the same way, when a body completes one square, let us consider r be the distance of each side. Now a body completes one full square. What is the distance? No doubt, r plus r plus r plus r, 4r. What about displacement? 0. So 6th and 7th class students, you have just idea about distance, displacement, velocity, acceleration and this. And I request the 8th class and 9th class students, you should be very thorough this type of problems, because after 10th, that is in the intermediate, the NEET and the JEE mains questions will be based on these formulas. So be careful. Until then, have a good day. Bye.